Open plan spaces should be designed for both privacy and for intelligibility. What we mean by open plan spaces is work areas which are not separated by ceiling height partitions. Think of classrooms and many office designs. Speech intelligibility is mainly dependent on three factors: background noise, reverberation time, and the shape of the space. Speech privacy is the degree to which speech is unintelligible. Sometimes you want speech to be unintelligible, like from one office to the next. And sometimes a high degree of intelligibility is important, like in the classroom. Long reverberation times, especially in the workplace, can have an effect on comfort. Sound that bounces off walls, floors, and ceilings can lead to poor communication and hard-to-understand speech, which can lead to increased stress levels, making it hard to concentrate, making people tire sooner, and leading to an increase in mistakes. So it's wise to increase comfort by reducing reverberation times with sound-absorbing materials. For instance, acoustical ceiling tiles. This can lead to easier communication, better concentration, reducing stress, and making workers more efficient, as well as leading toward a healthier working environment. So the goal of creating short reverberation time to help acoustics in a room is expressed this way in a laboratory setting. This chart represents a sound that is generated in the lab, then stopped, and the reverberation time is measured in seconds until the sound level drops 60 decibels. This is a simplified example of how reverb time is measured. And as we've said, the shorter the reverberation time, the more absorptive the space. Acoustical engineers have established ideal reverberation times in tenths of seconds, as we see here. Sound level is expressed in hertz. The chart shows ideal reverb times for several types of space. What are the factors that influence reverberation time? They are room volume, room shape, room surface absorption, acoustical ceilings, draperies, soft furniture, and so forth. And reverb time is strongly influenced by the number of people and objects in the room. People make excellent sound baffles. How short should reverberation time be for good speech intelligibility? Less than 1 second is about right in most circumstances. Here's more on speech intelligibility, which is important in so many workspaces. There's an index for speech intelligibility, the Speech Transmission Index, STI, that puts speech on a range between 0 for complete unintelligibility up to 1 for perfect intelligibility. There's another way of measuring speech objectively through articulation loss of consonants, percent alcons, in which the number of consonants that are missed by the listener is shown as a percentage. And still a third measure is Rapid Speech Transmission Index, RASTI, which is a simplified objective way of measuring speech intelligibility, less technical according to its proponents. Sometimes speech privacy is desirable. For example, in an office setting where intruding speech should be made less intelligible, or in a doctor's office where voice transmission between examining rooms is undesirable. Articulation class, AC, is a single number rating used when comparing acoustical ceilings and other sound-absorbing materials for speech privacy purposes. There's another rating system, Articulation Index, AI, that applies to completed office systems. Here's a range of ratings from under 0.05, which represents confidential privacy, up through the opposite end of the scale, representing no speech privacy whatsoever. Schools, in particular, have very specific acoustical performance requirements. The American National Standards Institute, ANSI, publishes criteria for equipment noise control. HVAC systems, electrical systems, plumbing systems, and instructional equipment. They set a limit for background noise of 35 decibels. This document discusses controlling reverberation with sound-absorbing materials, and there are recommendations for noise isolation between interior spaces, in open-plan classrooms, outdoor to indoor, and other topics such as impact sound and vibrating machinery are covered.